Welcome everyone. Today we're diving into the fascinating evolution in automotive acoustics, especially as we shift away from traditional combustion engines toward EVs.
Absolutely. It's really a dynamic intersection of engineering and design. And it's amazing how the sound, or sometimes the lack thereof, tells you so much about the technology behind these cars.
Right, exactly. For so many decades, that roar, the roar of the engine, was like the heartbeat of a car. But with EVs, that's completely
Yep.
transformed. Now we get a mix of tire noise, road ambience, and even the soft, almost melodic hum of an electric motor.
It's like suddenly you're hearing sounds that used to be drowned out by the engine. And it really opens up a whole new realm of safety and design challenges.
Absolutely. And speaking of safety, one of the major issues that popped up early on was, well, the fact that these cars are so quiet that pedestrians, especially visually impaired individuals, might not notice them. That's when acoustic alert
Right.
systems like AVAS really started coming into the picture.
Yeah, AVAS, acoustic vehicle alerting systems, became essential. But I mean, there's so much more to it than just a basic beep, right?
Exactly, it's not just any beep. Manufacturers began adding distinct, sometimes even signature sounds, like, uh, remember Nissan's digital whistle sound?
Mm,
And Toyota even experimented with a kind of spaceship tone that ties into their brand identity.
yeah, that's super creative. It really turns the vehicle's sound into a sort of a branding tool.
True, but there's also the technical side. Engineers have to measure every little noise and vibration in these vehicles.
Right.
And it's not as simple as just listening with your ears. They use specialized NVH, or noise, vibration, and harshness testing protocols.
Exactly. And that involves an array of equipment. Think acoustic cameras that can sort of see the noise, and even intensity probes and accelerometers that pick up tiny vibrations.
And I find it fascinating how they practically simulate the environment virtually before even building a prototype. It's like using high-tech methods to predict where the noise might come
Oh,
from,
yes.
like with tools such as SimCenter 3D.
And it's not only about virtual simulation, they actually physically test things too. You've got tests on different surfaces at various speeds to isolate sounds like tire noise, or even something quirky like the rear end rush noise that comes from complex interactions at the back end of the car.
Right. And that rear end rush, yeah, it's like this diffuse blend of airflow, window vibrations, and echoes in the luggage compartment. It really shows how every design choice influences the noise profile.
And I gotta ask, when they're tackling this noise problem, they seem to rely heavily on both active and passive noise control methods, correct?
Exactly. So, active noise cancellation, or ANC, works a bit like noise canceling headphones. They use microphones to detect unwanted noise and then generate opposing sound waves to cancel it out, like
Yeah,
Hyundai's RANC system, which uses a digital signal processor and even near field speakers embedded in headrests in some cases.
it's kind of like fighting noise with counter noise, which sounds almost like magic. But then there's the passive approach, right?
Right. Passive methods involve materials that physically block or absorb sound. They use everything from specialized foams to denser barriers, and even some innovative felt-based materials like Antonium's Flexi Loft, which uses recycled fibers. The material choice here is crucial.
Yeah, and it's interesting because they have to balance sound absorption with weight, cost, and placement in the vehicle's architecture. Every panel, every door, it really adds up.
Exactly. And not only do they consider the materials, but also how the car's design from the chassis to the bushings impacts overall NVH. Early design decisions can really make or break the acoustic performance later.
I totally see that. And then there's the whole new frontier of acoustic metamaterials that are being engineered at a microscopic level to manipulate sound waves in ways that natural materials can't.
Those are like something out of science fiction, right? They use phenomena like local resonance and Bragg scattering. And hey, they even have the potential to harvest energy from sound vibrations. It's mind-blowing stuff. A complete game changer in
Absolutely.
sound engineering.
Now, speaking of game changers, I've heard there's even an app out there for real-time NVH diagnostics using your phone. Isn't that wild?
Yep, The Weber Auto NVH app, for instance, uses your phone's sensors, sometimes connecting via Bluetooth to your car, to pick up on vibrations and diagnose issues on the fly.
Right.
It can detect things like first-order vibrations in tires, which might indicate potential issues, kind of a preliminary check for drivers.
That's really innovative. And it's also a sign of how much digital integration is becoming part of what we once thought was purely mechanical engineering.
For sure. And the collaboration among companies in this field is intense. Big names like Bertrand, Bruel, Kisser, and Siemens are all pushing forward with software and virtual analysis tools to optimize these acoustic solutions before any prototype is even made. It's a truly integrated approach.
Yet, I do wonder though, while the use of these advanced simulations is impressive, isn't there a chance that real-world variables might still throw a wrench into the works? For instance, what if the virtual model doesn't capture unexpected interference from, say, unusual road surfaces?
That's a fair challenge. I mean, even with all the simulations, the real world has its own quirks. But that's where rigorous dynamic testing on differing road surfaces comes into play, ensuring that models are constantly validated against reality.
Right.
It's a blend of virtual optimization